Welcome to this after lunch session, which is usually the most tedious session in the day. So we try to make it light. And hey, we just had lunch too. How do you like the tech conference so far? Good? Good. No? Boo. Yeah, so my friend Kishore and I, we want to talk to you a little bit about, okay, this is how I monitor my service health. I would say most of the topics have been presented before, but both Kishore and I, even though we are little different roles nowadays, we are both coming from a troubleshooting background. Kishore is in our solutions architecture team. I'm program manager for the on-premise deployment and for the cloud and edge deployment and for parts of the CDS business model and performance and reliability nowadays. So that's it. So I'm still having a good, good hold on our service health, and we say, okay, we give you some very basic things, which we talked already about last year in presentations. But then we say, okay, let's pick like 5 scenarios, which are probably very, very typical scenarios, and then we just want to talk to you about them. Like, so how are we tackling them? What were our experiences now with customers? So if you followed the keynote, we probably told you that we have something about 100 customers in production right now. And how are we handling these issues right now in production on our side? And basically, it's a combination of new and old tools we have to talk about. And we don't have much presentation on the old tools because, I mean, I assume by now every one of you is a good friend with SQL Management Studio and things like that, right? And, yeah, Eric back there shakes his head, right? He never seen that before. So we talk, some things we will just talk about, right? So, and if you want a little more data on, okay, how did I troubleshoot a SQL plan, which is bad, I'll talk about it. I don't have a demo on that, right? But long story short, we can delve into all nitty-gritty details there if you want to. But for now, we just want to give you like an overview. This is like how AX roughly works. I will tell you a little bit what is kind of the hardware we deploy in the back end. And then you can see, oh, these are possible things which could go wrong. Then Kishore will tell you a little bit about our telemetry and our telemetry pipeline. And then we just talk about 5 scenarios where we say, okay, some of them are, I mean, honestly, some things didn't change. And some things actually changed quite a bit. And then, yeah, we'll see that we get hopefully some good information for every one of you. So first things first, we talk about the architecture because understanding a product's architecture on a fundamental level usually is the first step to understand all kind of possible problems which may happen and all kind of possible things you can do. So I keep carrying this picture with me, even though it's like 1 year old, because it really helps explain what to look for and what possible like pitfalls might be, right? So let's look at the left-hand side where we see the old AX the old AX architecture, AX 2012 and before. And a bunch of the highlights are, well, you have a Windows client, which is a 32-bit client, and then you have, even though it's labeled AX32 surf.exe, a 64-bit server component. These communicate via RPC and via Windows Communication Foundation service calls. So then basically the client will host the user sessions, the server will host the user sessions, and that's basically on 2 separate tiers, right? So bunch of the problems you have seen there were, for example, round trips. So one, like everything will probably right away know is like how many round trips to create a 1-line sales order, right? Anyone take a guess? Right. Like about 100 to 120. So then obviously behind this architecture, SQL Server comes with many of the goodness, but also with the problems SQL Server has. For example, SQL Server only now came up with a sharding concept, and we can talk a little bit about that and when we will adopt that, if we will adopt it. But yeah, sharding, for example, to Oracle was well known since like maybe 20 years. SQL basically set up his first sharding concept right now. If you work with NoSQL databases, you know about sharding and the concept since a long time. So yeah, even relational databases support that more and more, right? So yet applications like AX have to uptake any new features like that. And you probably also closely follow the CDS sessions. Let me say that a lot of the work we do for LCS and the inventions will feed back into AX. So whereas LCS is a data platform which under the hood connects, if you, for example, follow the sessions on Product Graph, I think Konrad Volkmann may have a session there. We may have not only a relational database at some point under the hood. We may actually, right now it's a purely relational database, but at some point we may have a NoSQL database together with a graph database, together with like maybe a relational database under the hood, and then on top of that, an ERP system runs like AX, right? Essentially, more in the way of data platform of choice, whatever works best for a certain thing is best, and that will resolve a lot of potential performance problems which you will never resolve in a relational database. Anyone, for example, would have a good idea, besides a product graph, what would be really great for like a graph database? What would be a great application? Anything like a customer vendor aging, right? Basically anything where you have a history, a big application, which is, for example, a sample for a graph application, is like the Google index. Google is indexing the World Wide Web in a graph. So technically anything where you have many, many links and references to each other all can be very, very good. So and we are looking at things like that which will essentially transfer from where we are right now, relational single database, into massive scale and scalability in the future. So we have quite a few approaches there which we are evaluating. Well, but that is very far in the future, far out, a few years from now. Let's look at what we have right now. That's the new architecture, right-hand side. And there you see it's like an HTML5 client. So there's no session management. Essentially, it's a pure presentation layer. It's actually that what the AX32.exe, the old client, was supposed to be. It's a SOL presentation layer. There's no calculation work being done. Then we have a middle tier, which we call the interaction client, interaction service. That is on the left-hand side, like when you look left of the browser, and then between HTTP requests on top. That is essentially the communication layer between server and client. And then all forms and everything, like inclusive the session, everything is hosted in IIS. So why that might be important is it just highlights the fact that the AOS is doing more work nowadays. It needs to host the form state. It needs to host the object state. All the client is doing is communicating and transferring that state. But at the end of the day, the whole hosting of that state, managing of that state happens on the server. The AOS is nowadays a pure DLL, living and breathing in IIS. So from there, that's just to help you understand how the rough layout is. The batch server is still an own exe, so batch.exe. Right now, if you look at that, so essentially you have the Azure Traffic Manager, the Azure Load Balancing, in AAD for the sign-on. And then, like in the past, you have a set of VMs. So you have a bunch of VMs for management reporter, you have a bunch of VMs for the AOS, and you have a set of AOS for like which SSRS uses to communicate for security. Then at the back end you have a data warehouse, aka entity store, and you have the actual SQL Azure database for production, and you have the Azure blob storage. The blob storage we use for many async. For example, if you take a trace with trace parser nowadays, trace gets stored in blob storage. If you take a task recorder trace, may get stored there, right? So we use it to store all kind of interim data. So what's important to know for whenever you build your own processes, you evaluate, for example, you run integration with DRXF. Everything high volume batch processing, right now there's no separation, and that's like a little flaw in our architecture and the deployment between batch.exe and IIS. So it means they're always co-located. Each AOS has a batch.exe and an IIS. And you cannot very easily break that apart right now. That is like something we have to fix in a future release very soon in my mind. I see that in more and more feedback from customers when they try like high volume integrations with DRXF. We see that just, well, yeah, we can throttle down the batch server and we can limit the threads on the batch server, but ideally you need to be able to have dedicated batch resources, particularly if you are a high volume processing customer. And that feature, you kind of can make it happen, but it doesn't come easily right now. So it's, and we look a little bit at the current configuration, at the throttling mechanism, just a little later. So it's the basic architecture of AX, a basic overview. So under the hood, very similar to what you know, very similar problems. The round trip problem is not there anymore in the sense of round trips from browser to server. Creating a one-line sales order is maybe 4 round trips, and I'll show you later how to see what round trips you're doing and how the communication works. We have a demo for that. To the database, the AOS is still a chatty program. And as I said, we have all the power, but also all the problems which come with SQL Server 2016/SQL Azure. The SQL team claims feature parity there. They're pretty close, but yeah, things like the new cardinality estimator may sometimes throw an execution plan off. All of these problems still exist. All right. And with that, I give it over to Kishore.
So here we see. Can you hear me? Yeah, good. So here we see the architecture that enables our services to do monitoring, diagnostics, and analytics. Basically, this is what we use across Microsoft for all our cloud services. If you see the underlying components, they are all capable of handling super high volumes of events that are getting generated from all these cloud-hosted environments. As you can see, some of this data is available on the LCS pages. Most of you must have seen these pages. This is how we process the data and bring it onto LCS so that you can monitor the health of your service. But a lot of this it stays back within Microsoft for support because things like events, event logs, these are probably not so useful for you guys. So a lot of this is maintained within Microsoft, but good information that at least helps you understand whether your service is running, whether the service is in a healthy state. That information is available for you on LCS pages. So if you see on the left side, most of these data that is coming onto these pages is actually processed by something called monitoring agent. It's a collector service. It's present on all cloud-hosted environments. And the way it works is it collects a lot of events, like performance counters, ETW events, Windows logs, IS logs, Windows events, and even crash dumps. And in addition to collecting all of this, it can even perform some sort of an aggregation. For example, if an information is not required at a detailed level, it can aggregate. It can even filter out information that is not required and send it over, send this data over to multiple data pipelines that you see here that eventually end up in those LCS pages that you see there. These data pipelines, each of them cover different scenarios, and each scenario has different latency requirements. And if you see the one on the top, we call it hot path, and it has the least latency. The data that path processes, they are available within 60 seconds on your LCS pages. And this information, I mean, it's possible because of the MDM that we have here. It has near real-time capabilities of collecting and processing data. It can handle high scale with very low latency and with very reliable alert system. So this is what we use to monitor the health of your system and even create health alerts automatically based on what's going on. For example, I think there's a ping event that gets fired every second or so, and that's checked to see if all of these components that are running in your cloud host environment are running properly, or if there's any problem, we can even do some sort of an auto recovery procedure quickly so that the downtime is not long enough. The next one is warm path. Here we just, this enables us to do more of diagnostics. It's not like, allowing you to check whether your system is in good health or not, but it allows you to see what's going on in your system, what activities are happening right now. So more of diagnostics. If something happens and if you have a problem, we get into this information to see what really happens. Kind of a big database for all the event logs from all the environments. And finally, the cold path. This is the slowest of all because it's not exposed to anyone. It's an internal thing which we use within Microsoft. Basically, what it does is it performs complex, very high, large-scale analytics on operational data so that we understand how the business is running. We have many metrics, many BI dashboards based on this data. And as you can see, we have something called Scrubber, which takes out all information that identifies a customer or any data that they have. So it's basically just analysis of what really, how the business is running, like how many forms have been opened in the last 1 month, or which forms have been the slowest, what are the most used data flows within AX, things like that. So if you go a little deeper into the hot path that we see there, as I said, MDM is very fast. It can collect information. Basically, as the name suggests, it's multi-dimensional metric. It collects metrics in different dimensions, and it does that in almost near real time. So it allows us to send this data immediately to a health system, and the health system can actually look at characteristics of this data that is received there. It processes it, and we can create rules there that identifies if there's any problem and do certain actions, custom actions or inbuilt actions. Like we can create a ticket if your system is experiencing continuous sustained threshold violations for, like, let's say 5 minutes or 10 minutes. Warm path, which has about 5 minutes latency, is essentially transferring all the ETW events from monitoring agent to something called Custo. And this is the name we use internally within Microsoft for application insights. And the data that is stored here is used by our service engineers. Very limited people have access because there could be information related to the customer there. So we have very few people, or at least authorized people, can use this system. It's not very few, but I should say it's authorized set of people can use this system. And some of this data is also being sent after stripping out the customer information into the analytics database, which can take many tens of minutes because we perform a lot of scrubbing and a lot of complex operations there. So at the end, you have mainly three things that this architecture enables. You can monitor your usage of your system, like you have AOS, for example, what is happening on the AOS. You have retail components, you can check what's happening on the retail component. Like, for example, there are some functional counters that get exposed on LCS that lets you understand how many calls you're making on the retail component. Or you can see what is my memory usage on the AOS. Maybe you can use this to help tune your batch, for example, like should I run with 4 threads or should I reduce it, or is my threshold automatic throttling working on batch. Things like this can help understand whether you have room to grow or you have to tune your system to reduce your resource consumption. The diagnostics, as I said, it helps you identify what really happened in your system at a particular time or 5 minutes ago. We use this extensively to figure out if a customer asks us, what really happened in their system. I mean, some are still trying to understand how to use this system, but we help them out by showing them how to use this diagnostics environment monitoring pages available on LCS. And in the next slides, I'm going to show a couple of issues for the common issues that we hear from customers and how we go into LCS monitoring pages to see what really happened and how we can understand or infer the data that's there on those monitoring pages.
Eric, you had a question over there?
How many of these limits data are going to be exposed to CS? Can I get a CS notification on LCS?
I'm not sure if I understand your question. You said something about what is exposed in CDS?
Yeah. How many common data sources can I do publish? All these data that are going into CS.
Yeah.
Can I make common data services my own notification?
Yeah. So the question is, can I basically use CDS with LCS together and get own alerts? Can I create an app which is basically help me monitoring my X system? So I think we'll do that at some point, but right now it's really not on the roadmap. So if you see how CDS currently works, it's basically the data platform dedicated for Power Apps and for Flow, right? And at some point, what you have seen in the demos, for example, from Peter Willardson, it becomes his own declarative experience, his own SDK. And the more and more that comes, the more and more such scenarios may be possible. But right now, we don't even have it even close on the roadmap. So I would be happy to speak about it. So I'm more like, it's just not even yet on the roadmap right now. But I think scenarios of like those will be asked for and will come on the roadmap at some point. But right now, it's just not. And I think it is something which makes sense, actually. I would agree with you.
Okay. You have a question?
Yes. So whatever you're calling as the cold path is the only thing that we would not have access to. But everything else in what we see as a hot and warm, are all those tools available through LCS?
The question is like what we see as cold path here is what we don't have access to, but everything else you can see in LCS. So the answer is almost.
Okay.
So the cold path definitely is something you cannot see. Whereas the cold path is actually an aggregation of the other data anyway. So you can see it. Now the question, if you can see everything else in LCS, the answer is yes, with a lot of patience. So, and why? Kishore will show you the raw log. Well, to filter that raw log in a CSV file or even only directly, it's kind of tedious. It shows you only a limited amount of columns. So there's like this thing like called Custo on this slide, right? That's like essentially a sort of Elasticsearch in the index across the telemetry data. And we expose some of that in LCS, and we have queries on top of that. But those queries are kind of, let me say it like, they're very limited. You cannot freeform write queries against it. So it may, as I said, it needs some time and understanding of the telemetry to be able to pull things out of the raw log. So it's you'll definitely invest like a few hours to a few days till you can basically make that work for you in the sense of if you want to go outside what we give you with the canned queries. If you stay inside of that, it's easy. It's easy to use. Kishore will show that in his demo in a second. But if you want to go outside of what we give you in the UI of LCS, then it gets a little tricky.
These tools are supposed to be available for any hosted D365 environment. It's not just a production or...
LCS is available for sandbox and production. And for dev, you usually wouldn't need it because you have literally all access. You can debug at any time, right? But for sandbox and production, you can get that data out of LCS.
So on the sandbox, you have no access to the environment monitoring because you're not really interested in understanding the health of your system during that stage. But whereas diagnostics is available on sandbox environments, and on production, everything is available. Just to add what Christian said, the information that we collect is much more than what you really need, and all this information that we don't show on the LCS page is something that we use internally to understand how the code path has been, which code path has been used to perform a particular operation, the events and logs within the code, that fired those records that get logged into this Custo. So the canned queries that you see, or I will show you later, are the ones that are more meaningful or that you can take action on. Rest of them are just Greek and Latin, which is probably only even people who know Greek may not understand. So again, just to cover what we discussed. Yeah. No, it's you just have to mention that. So the question is, if a problem happens in the system and if you create a ticket, is all this information uploaded along with that ticket? The answer to that is no, because this information is already available to us. And most of the time, if it's, for example, if it is a crash, you don't even need to file a support ticket because, as I said, the health monitoring system takes care of looking for crashes and automatically creating tickets for them. And there are other scenarios where tickets are automatically created and someone will look at them. Each of these tickets will have different priorities, different severity levels based on what the real problem is. But what is more important for you to provide during the ticket, in the ticket is what time it happened. If it is not captured by something that we monitor, that time will help us identify in the tenant what really happened during that time, what else, around that time it can give us clues about what could have caused the problem. Yeah. I think on LCS there is an ICM. On LCS, where do they create tickets?
So you can create support tickets via LCS right now?
Yeah.
Can you speak up a little bit? I barely understand you.
Okay, so you mentioned that when the crash will happen, you create a ticket.
Yeah.
You create that customer BSTS so that it might
Oh, no. That's two different things here Kishore has been referring about. So if we go, so there's a way you can create tickets in LCS, which is a regular support ticket, and then this agent called monitoring agent, which lives on each AOS, works in the following way. It is essentially uploading each crash to Azure Watson. So, and then in Azure Watson, we basically have a tool which runs against Azure Watson and sees, is there new crashes inbound which we don't know? If yes, create bugs. Actually, these things we create in our own dev system as bugs. Crashes are treated different than regular support requests. We work on crashes nowadays proactively. So if we detect crashes, we fix them under the hood, and then as you maybe heard, we ship monthly nowadays. Each month, we basically improve our product quality and just feed in new crash fixes if there's any. So we treat those in a different way due to we feel there's lots of urgency of doing that. So we essentially continuously stabilize if there's anything. And through that, actually, we did that already early in the release. We do that almost 2.5 years now. Through that, actually, the product quality is actually pretty good right now compared to like other releases. If you look at 2012 when we shipped, how the release quality was, I mean, yeah, you can always find things. You will always find things, but we are way more proactive about things too. You would see the crash. Kishore will actually show you where you would see that in just a second. It's kind of pretty obvious right there, and when you open the activity monitor with a red X, it's like.
So yeah, the Custo.
Yeah.
Sure.
Yeah, we'll do that.
Yeah. So the Custo, we have a team dedicated to actually look for patterns of issues that our customers are facing, even some patterns that you do not see or users do not experience are being captured and proactively being worked on. So monitoring, it's high scale, low latency, reliable alerts. It's available almost real time. Diagnostics, this is what you see most of the time as you land into LCS page, LCS environment monitoring pages. It's near real time, but not as fast as the monitoring. This is what you would be spending most of the time to do your day-to-day diagnosis of issues your users report. And analytics is totally inside one. So I'm going to jump into the LCS monitoring page. Unfortunately, we can't use any of our large environments that our customer environments basically. So I've set up a demo environment where I was the only user, and Christian helped me drive some load, but at least we can go through a lot of these options or the paths that we can follow to find what the root cause is for certain common issues.
Essentially, Kishore says we'll have to stay a little theoretical here. By now, we have really a lot of like cool samples, but for that, we would need to show you customer data, which we can't. So, but we'll talk through the issues. We say, hey, and this is what we did, right?
And
so, this is how we used the tools we had, and this is where we couldn't use the tools, and that's, I think, even more important for you, that we say, and here we couldn't use the tools. Here we had to do like funky things, like get a backup back to Sandbox and start debugging against it. So we also tell you when that happened or when that will happen. So try to just give you options. So you say, okay, when I work with the service, how long can I go with the tools I have? When do I have to lift the hand and basically do funky things or go to old school methods?
So let's look at the common problems that we hear from customers. The main problem I hear is, particular processors are slow. This is for customers who are like stabilized. Like always, there are teething issues when you have, when you just go live, and over time they settle down. But as soon as you go live, the first complaint we hear is everything is slow. And then over time, the issues happen at specific times, and over time it's just 1 or 2 users who are having issues. You need to know what exactly is happening when a particular process or particular user complains of a particular process being slow. So let me jump into AX LCS. I'm already on the LCS page, environment monitoring page. For those of you who do not know how to, yeah.
Sorry, what I understand of the showcase you want to create now is the full system is slow. It's typical a user said the full system is slow. But then you respond on a request, so we create an issue and say, hey, the full system is slow. And then we go into that process, right? Because I expect that you recognize, oh, we have a problem. Maybe you can slow down the system, and you actively work without the need that I have to face the issue.
It works a little different than that. So the statement is, you would expect in a service world that we would actually let you know that something is going on, right? Let me elaborate that a little bit, how that actually works. So right now, every AX customer is attached to an engineer, to a fast track engineer. So you have a very direct contact to a person, which is, he's like, I would say your Microsoft representative right now. That's called the fast track team. So now, besides that person working with you and telling you, okay, maybe this is how you monitor, this is what you look for, we also have alerts, and we also have a weekly review of how we do and how the service is doing, in which we look at, was there any DTU spike? DTU is the new measure of how SQL measures performance. It's basically a combination of CPU, memory, log space, log write performance, and a bunch of other factors which comes together in this DTU measure. So in the service where we look at, okay, was there any DTU spike? Was there anything particularly bad? Was there any crashes? Did we have to do anything? Obviously, we don't only look at this once per week. There's a team working on that all the time, our service engineering team. But we as core, like Kishore and I said, we review that only once a week. And we get looped into these things like during the week on a need basis, right? For the rest, we have the service engineering team and the fast track team. So would we always notice whole system is slow? Probably not, right? Would we always like just come to you and say, hey, there's an action item on you to open a request? Honestly, if we already know, we probably don't even ask you to open a case. If we know this before you, we will do something about it actually, right? But so we'll inform you and we'll say, hey, we think we need to do something, but So it works a little different. That's all I wanted to highlight. Yeah. So, particular this case, I think this whole system is slow. We just had it with a bigger customer going into production, and they actually claim, well, the whole system is slower than AX 2012. So there are some specialities to that because, well, first of all, we measured on the same database size, on the same record, the same process. And we figured out, no, it's actually equivalent. If you really do the absolute same thing in AX 2012 and AX7, the performance was actually equivalent. But they said everything is slower, right? So we had to go to, there was like just one exception. We used these tools, and Kishore will show you more about it, but we also had to really go and compare and say, so I spent actually a few days on site with them. It's like, hey, let's compare these things, right? So we went, oh, in AX 2012, now select this record and now post your journal, right? Exactly that one. And now let's go to AX7. And that was in pre-release stage. They were not in production yet. So part of the pre-release process is that you test for performance and do UATs, right? And that's a fixed part in the methodology nowadays. And when we ask you to do these things, and most customers, and also thanks to the fast track team, nowadays really do that. And then through the fast track team, we get many of these issues before the customers go in production. All right.
Okay, so let's jump into this diagnostic monitoring page. So the first graph, let me go through the individual things that we see here and what they show, and then we will go through the flow of how to identify or how to use these in a particular flow to identify the problem. So the first graph here, the top bar here shows you what time you are interested in to look at this information. I did not mention how much, what is the retention period for this data when we are showing the architecture. So all this data that you see on these pages, it's available only for 30 days. So anything older than 30 days, you cannot really retrieve. So if you have a problem, act fast, resolve it before 30 days, or just collect this information and keep it. Here you can say that I want to look at this time and 25 minutes before this, and the graph, the chart here that you see here, this is an activity chart. There are two scales here. On the left side, you see the number of active requests. On the right side, you see the SQL utilization. And SQL utilization does not mean CPU or any specific component. It's a DTU combination of all the resources used there. And the legends that you see here are clickable, so you can actually disable something. And if I don't want to see SQL, I can just remove it from the graph. And so on. So for the other AOS and other components there. The user load is going to show you each of the machines, each of the servers that you have in your environment, what is it doing and what component is running mainly. So in this case, it's mainly batch activity on this box. You can see that there's a little bit of batch, but a lot of interactive sessions, and obviously this is dedicated for MR, so it's doing just the MR related work. And it also identifies how many users currently are on that particular server, and this is an ID that we can use to identify the user name. This is not available for all of the users of LCS. It's only available for people who can log into AX, which and to a module called users. Only those people can identify who exactly is that user. And the next one is an activity load. Here it identifies the individual operations or individual forms that are being used on the particular server. In case of batch, it shows which batch jobs were running. And the last one is the user activity. So there are two things here which are not in any specific order. It shows an aggregated view of whatever happened during that time. So if you want to look at the series of actions that resulted in this kind of workload on your system, you want to come to this user activity area where you can expand and see each user session and identify the individual actions that happened on that particular user session. It could be more than one session for a user depending on how long you are looking for here. So this is your landing page, and you have other things here called health metrics. This is the health monitoring one, the hot path from the architecture, and then the SQL insights and diagnostics. Diagnostics is a kind of a custom job that runs on all the servers to identify if there's any issue or anything, what status of multiple things. It can even alert you if it sees that there is some scope for improvement. For example, there could be a number sequence that is not being set to perform. It is an option available. It will highlight it. It's up to you to use it or not to use it. And the SQL Insights is the one where we spend a lot of time when we see performance issues. And this is also the place where we spend time for identifying or identify the needs for maintenance. Like, is there any SQL that is more expensive or consuming a lot of resources on my SQL server? So within the SQL Insights tab, you can see there are 3 sub-tabs. One is for performance metrics, which is mainly duration, I/O. This is the main driver for DTU. So you want to come here if your DTU is high or if your SQLs are running long and see what's really happening. Index analysis is again a maintenance thing. So if you want to see which index is being used more than the others, you can come here and check that. And SQL now is kind of real time. You want to see what is currently happening in your system. This is where you come. And this is very useful for identifying blocking queries or like what logs have been acquired or what are the SQLs that are currently running, what is the I/O for those SQLs. So basically, this is where we start if there is an active problem going on right now.
If there was a blocking scenario, what would we exactly see in the SQL now tab?
So if there's a blocking scenario, you won't see so the blocking statements will be showing up here, which will have the blocker and the blocked query, and also other information like how long it's been blocked and what is the session. It shows a batch ID. I don't think it is a session ID because when we look at it from the back end, it's a different one. So
if you want to go back on activity really quick. I don't know if Kishore, did you mention the user ID? You can figure that one out. So
yeah,
this code you can get that in AX. Maybe you should quickly show it.
Yeah, we can show it when you
dig
it up. Yeah.
Or I can show it later.
So there are a few interesting things that you can do here. One is to focus on certain area from here, or you can actually go into a particular thing. Like if your batches are running fine, but you want to see if your interactive sessions are slow, you can click on interactive and just filter on that. Let's say you have everything running slow. What I would look at is, am I out of resources? Is the environment having room to actually perform? Is my SQL in a healthy state of like 50-60%, or is it at 100%? I can even go into health metrics to see my AOS or the other servers, whichever component is being slow, you can see how the utilization has been on that particular system. This in fact can go up, like if there is a pattern that you see, like every day at this hour I see a problem, you can even go up back to a day, week, month to see is there any pattern to your utilization. And you can go into even a custom time period within the last 1 month. And if you're not interested in certain resources, you can disable them, you can zoom them to look at a bigger chart.
So user ID would be your suggestion to look for my way to track back to see this query is what, because I mean with the X that's kind of the thing, right? When you want to trace back to this SQL query, what exact action inside X++.
Yeah.
And I always had to end up not just being SQL, the SQL Server activity monitor itself is never enough, because you have to do something like a tracing cockpit to see what X++ line of code is ultimately triggering this SQL line. So I was just wondering if there's an easy way for me to.
So the question is, how do I get to the user behind a certain user ID? So how we will keep that feature working in the future. So there's something coming with that. For our compliance efforts, we need to randomize this user ID. Right now, what you can do is you just go to the user table, you copy the user ID, and then you can basically resolve that and see, oh, this user did that. But for compliance reasons, we will need to change that. We need to completely randomize this ID, and then I feel the use of this first kind of chart diagram will go away. You have to kind of make it maybe put at the bottom of the page, and unless we can keep that feature that you can go over to the client and somehow figure out this user actually did the action, this is not very useful, right? And right now you can do that. For the next few months you still can do it, and then we have to figure out how we keep that feature and be compliant at the same time. So the other thing is in the raw logs, which Kishore will show you at some point, you can see slow queries. Now, every query which takes longer than 100 milliseconds, we log. So that gives you the call stack, and that gives you some pointer where in the code it happens. So it's basically, if you know the SQL statement tracelog of AX in the past, that's the SQL statement tracelog of AX in the future. I will show you that. But the problem with that is, so to say, besides these two ways, we still need tracing sometime. We still need other things. So there's still a gap, right? For example, if the DTU is like close to 99%, you will have a lot of slow queries, and that really doesn't have anything to do with the query. So can you go off that information? No, you can't. Eric?
You're only storing data for a month right now. Are there any roadmaps in the future to save these data in a graph database or something, so we can start doing trend analysis and so on over a long time?
Let me repeat and see if I understood you. So we store this data only in one place right now.
No, 1 month.
For 1 month. Oh, okay. So we store the data only for 1 month, and are we storing that for a longer time? So yes and no. So right now, the cold pass data Kishore has shown is stored for about a year. The other data is stored only for 30 days. So the data we store for 30 days is very vast. So technically, you can even get like a sort of a stack trace. And down there's this table of the user activity. Kishore could actually show you. If you expand that, you can see every action the user did in the user interface. So you see all the steps the user took. You see where he clicked. So this detailed data plus more we store for 30 days. Some general trend data that someone used the sales table list page, we store for like a year. So that's an aggregation of the data. And we do that already.
But if you want, you can download this information and store it in your own database for future analysis. To some extent, yeah. Yeah.
That would be a task, but come on, go ahead.
Okay. Have you considered to make this like a project attached? Because we have a formal complaint or something and keep the information in that way. Just like you do it for the network project, if you make an environment monitoring project, this was the complainant.
Oh.
And relation to that. And this one is the one who actually did the monitoring, and this was his result.
It's an interesting feature request. So the requesters could be somehow store certain project patterns away and then basically have them for a later review. Yeah, it's a pretty good suggestion. Let me go back and think about if we can somehow do something like that. So right now it's not on our plan, to be honest, but let me think about it a little bit. Yes?
Can I just point to the sandbox or tier 1, tier 2 environment, or just for production?
No, you have that also. So the question is, can I see that for tier 1, tier 2 environment? So as far as I know, it works for sandbox and production, but not for any of the dev systems. There was a question in the back. The gentleman has been raising his hand. Question is, can we set up our own alerts? Not right now. That might be coming. I would need to check on our roadmap for that. The question is, could we consume this data by ourselves in Power BI? So that goes back to Eric's question. So this API is right now non-existent. To be very honest, we tried that in the past. We tried that actually 10 months ago. And actually we tried to make it visible for you in Power BI. We tried to create all that for you in Power BI, but it didn't work quite out as very well because of all the compliance requirements we have. So AX tries to be ISO and SOC compliant, and for that we just couldn't make it work in a compliant way. So that's why, and then we never revisited that. So I think that's why I say to Eric before, we will probably revisit that, but it's not on our plan right now because there's lots of other things going on. Yes?
You said that queries longer than 100 milliseconds, but often the problem is not one query, it's the number of times it's executed.
Yes.
Is it a possibility for train to filter out this and see if it's...
Yes. The question was, well, we log only the queries which take more than 100 milliseconds, but very often the execution, the amount of executions is rather the problem than the actual query itself. And the way to see that is SQL Insights, but then you will not see the call stack. The Kishore will show all of that. Maybe we let him go a little more in his demo.
Yeah,
and then
yeah. So you can actually see that information on this page, but it is only for a specific period. But on the SQL Insights tab, you can actually go in and see statistics for last 1 month. How many times it has been executed, or in the last 1 week, how much of the resource was consumed by that particular query. So anyway, we're running out of time. We have a few more things to show. Let's keep the questions at the end, in a few minutes at the end. So let's look at the scenario 1. The whole system is slow. Most likely it is your resource consumption. As we said, we can look for all those metrics here. You can see if there is any activity at all, or the system itself is blocked. You can look for that here. And the second thing is the SQL Insights tab, where you can see what are current running queries. Maybe recently we worked with a customer where they have one common table for all their key users, and if they complain, it is a serious complaint. But we ended up finding that the table was blocked, and it was, everybody is just waiting on that table, and you could just easily find that here by coming to blocking statements and see which table was blocked, and what are the levels of block that was acquired on that table.
So in that case, we could have had more session IDs.
Yeah, exactly. And you will see a big list of current execution statements, a big list of blocking statements, and a few locks. And locks are not always a problem. For example, if you're running a data import or something or you're running a bad job for like end of day posting, it is obviously going to touch a lot of records, and if you are touching a lot of records, it's going to escalate the logs unless you have explicitly said not to. So in those cases, you will see logs, and you have to understand that these logs are there for a reason. That's your job. If it is not the case, then you have a serious problem, or you might have some problem that you have to go and troubleshoot. So you can also look at this, occasionally, every other hour during the first few weeks to see if there is any query that is coming more often that's appearing here more than, or you just recollect that you saw this query again some time ago. And that's a good way of tracking some of these queries to see if they also end up in this performance metrics tab. And this tab here shows data for each expensive query in terms of duration, logic, I/O, and CPU. And here you can actually even see if I click on something, and if that is also causing I/O or also causing CPU, it will highlight those bars as well. And you could even come down and look at that statement or look at the trend of how the query has been performing over time. You can look at the statistics that someone asked earlier, how many times it was executed, what is the wait time. So this gives us an idea of whether this query was executed without any logs, or it's been waiting most of the time. You can even download the query plan. In the future, Christian will talk about other features that will help you do some sort of self-service for these problems. Right now, we have to make the changes in your code and bring it and deploy, or ask someone or request someone in the DSC by filing a service ticket to take care of this problem. And if you don't see the real or the current data here, you can always start the collection anytime on demand, and after a few minutes that information is available to you. Now coming to the other problem, which is a particular user is complaining that his process is slow, you could just come here and see that, okay, what is triggering that slowness, or what is really happening in that session. Sometimes you may not have, or the user may not be able to give all the information that you need to understand what really went through there. In that case, you could actually see that, okay, within this period, is my user ID there or not? Or it's probably hard to find out because it's a GUID, but at least you can see by clicking each user here. If there were multiple users at that time, you could actually, you will see that more blocks for each user, and you could click on that particular user. For example, I can just click on this user and see what that user did. So right now I clicked on that user, it has filtered out activity only for that user. And if you said the problem was in a particular form like sales table, you can click here and see what really happened in that particular session of the sales table. And you can also see if there were any messages during that time. You can even filter out, or you can see more details about that in the view raw logs section. This area, it gives you more information about that particular, within this particular time, with whichever is containing sales table, you can see what really happened. This is an all logs view, which I don't think anybody would really find it useful right away unless you invested some time in going through what it is. But slow queries is a good start. You can see what queries and how long they were run, they were executed, and what call stack it originated from, how many times it was executed. There are other interesting things here: connection outages, slow interactions, which are more of form interactions, which are slow. Is batch throttle is something that you expect it to run during the night. You expect it to run full scale, but for some reason it's not running full scale. You can come here and check, okay, whether my batch was throttled because of some resource threshold violation. can see crashes, deadlocks, all events for a user, and this list will grow as we find more interesting things to add here. You can always clear filters and start all over again.
I think we can show the other demos.
Which one?
Should we go forward? So I think for the interest of time, so do you have any specific questions to any of that? Because I want to show maybe 2 more quick demos and maybe open it for question for 5 minutes. So yeah, if we would talk now in detail to the other scenarios we had, well, I guess we'll be here for a few more minutes, like half an hour maybe. So I just want to show you 2 things which are somewhat newish and important to know with AX7, D365 for operations. And that's, if you come to the point, which we came actually both in our troubleshooting for quite a few times now, that all the cool new stuff you're seeing doesn't help. Well, the old school tracing is still there, and a few other old school things are there. And sometimes you will just end up, or well, sometimes, particularly in pre-production, to restore the database, file a ticket, restore the database to Sandbox, or well, by now there should be like a self-service feature pretty soon to restore that and get the database to Sandbox and troubleshoot there, basically. That's just happened to us too in many pre-releases now in 2.3, and then it's just, so if that happens, well, I think that's just, you cannot do everything with telemetry yet. We want to feed that more and more. If you need to trace, there's trace parser. You need to have a specific role to start stopper trace. You need to have the role called systrace role. And then you can, after you did a trace, you can see all the capture traces. And this role you need to assign in system administration under the users. You just give the user the systrace role, and then he can actually trace. You as admin then can see the traces he captured, can download them out of the blob storage onto the disk, and can basically start working with them. The other thing I wanted to quickly show you here, 2 more little things, is if you do any like batch processing, high volume processing, the system configuration, server configuration, sorry. The server configuration has this throttling setup down here. And basically, if any of the batch processes would consume more than 75% of CPU or more than 95% of SQL, or whatever you set there, we would start throttling that, so we would not add new requests. So obviously, for a live system, sometimes you want to set that to much, much smaller values. You maybe want to set that like to 30% only, right? Or to 50%, because you want to start throttling your batch faster. You don't want the users to be impacted at any point in time. As I mentioned before, there's no clear separation between batch and AOS in the sense they're all in the same machines, right? So right now, we'll try to change that. Then you still have the whole batch server configuration, thread settings as you knew it. And one tool for just in production troubleshooting is not the F12 menu. It's actually the perf timer. So when you type debug equals develop, behind any URL you get this thing we call the perf timer, which tells you what is going on basically in the background. So you can see, oh, what server calls did I have? Did I have any slow queries with that? So it's a nice little tool for you to just see, oh, why is whenever I open all my customers, is that firing particularly many queries? One of you said, hey, sometimes the amount of queries is the issue. Well, sometimes it's also a specific query. So you can go into the server calls, and you could see, oh, was there anything? So longest SQL execution time, 212 milliseconds. So that was maybe not it, but 14 SQL queries have been executed. So you can kind of see, and it totally took 260 milliseconds. So it's probably not that. And then you can see, okay, how much of that time is attributed to the client operations, to the server operations. So nice little tool, particularly when you know how to use it together with the F12 menu, where you can see on the network trace, if I go anywhere, like all vendors, let's just open it again. You can see these times here, and you can expand that, and then you see the time to first byte. Time to first byte is essentially the actual response time. So that is how long does it take till the first byte arrives on the client. So you can see how much time is actual server time of any A operation. And then what you need to look for, if you look for actual AX operations, is process messages. This is basically, whenever you see a process message, that's the round trip. So looking at the process messages, you can see, oh, okay, so time to first byte, so this round trip took about 86 milliseconds in total. That is server time plus latency. So every few minutes, we also have a ping here, which tells you the current latency. So knowing the F12 menu, the perf timer, trace parser plus LCS, most of all, plus a few nitty-gritty tricks for Sandbox. That's how you can basically figure most of the things out. I think now we have like a few minutes for questions, 2 minutes to be true, and then, yeah.
That what you showed, sorry, that what you showed, do you allow us then to do the production?
Which one, the perf timer?
That one, the feature that you go in and do the develop, blah, blah, blah.
The question is if perf timer is available in production where you say and debug equals develop. Yeah, you can do that in production. Anytime, any second. Any other question? Yeah?
So I have just a general question. So if I'm a prospective client,
Yeah?
okay, I've got a flat fee per month, it covers everything I need to run this. Who's really responsible for this tuning? Is it me as a client, my partner, or is it the Microsoft team?
So the question is, who is responsible for the tuning? I would say the answer is depends on where the problem comes from. If it comes from the code you add, well, you. If it comes from the code we add, probably us, right? So it comes from the data constellation the client has, well, both of us. It's in our own best interest that every customer has a great experience, obviously, right? So we'll always help. We'll always be there no matter what. If it's a bug on our side, obviously our problem. If you create new code which slows things down, well, obviously you will have to help, right? And you will have to do things too. But it depends, I would say, is the answer. There was another question. Yeah?
These tips or tricks that you showed in the very end there, quite cool, of the networking and this debugging accessibility. I just don't know, is some information about these things available on the app wiki?
Uh-huh.
How to do these things?
The question is there information on all these things we just shown available on the wiki? So SQL Insights and the Activity Monitor, there's not much there yet. I actually have the task, so Manalia, the PM for it, asked me if I can do recordings. I will still have to do these recordings at some point. But the whole perf timer, perf SDK, trace parser, and parts of the SQL Insights is documented on the wiki. So for most of the things there is data available. The SQL tuning part is like slow queries and these things. We want to upload a few short videos, but I have to produce them still. So one more question, and then, yeah.
I've seen the diagnostics tab on the program, the example system.
Yeah.
I'm not seeing this on my production system, which is running on update 2. Is this the one? Something new? Or?
Yeah. So we just added that diagnostics tab. I would think, I don't know the root. So the telemetry team and I, we discussed it a while back. How can we basically, in the past we had health metrics, health monitors there. You might still see the health monitors. And instead of showing these health monitors, which were a little ambiguous, we just want to show if things are wrong. And that's what this diagnostics tabs will be about. Yeah. Okay, last one.
What kind of trace flags are active as to actually like 11s?
On SQL?
11, 17, 18,
Okay.
log escalation?
The question is what trace flags are enabled on SQL. Due to my knowledge right now, none. All right. With that, yeah, let's close. We were out of time. If you still have questions, just come up front. We are here for a little bit. Thanks for coming.